What's up, everyone? Today we're talking about chemical compounds. So, we've taken our time looking at atoms, and we know that matter, as we know it, is made of these tiny atoms, tiny, tiny things called atoms, right? And we looked at structures of atoms and qualities and all that stuff, but it's really important to emphasize that rarely are atoms by themselves in nature. They combine together to make compounds. So, water is H2O, two atoms of hydrogen and one atom of oxygen combined together. So, in this video, what I'm going to do is I'm going to teach you how to make formulas of compounds given two atoms. So we need to know the rules of how atoms form, and I'm also going to teach you how to name these compounds, right? So if after you get the formula, can you name this? And then from that, I'm also going to teach you how, if I give you just two compounds, you'll be able to find the formula, name it, and if given the formula, you'll be able to give me, or no, if given the name, you'll be able to give me the formula just from that. And from this, you need to know, originally from our previous videos or lectures, you should be able to know um, how to find this particular atom, how to be able to tell how many electrons, protons, neutrons that it has, how many valence electrons that it has. That's really important. And how to do a Lewis structure. And the Lewis structure is going to show you how many valence electrons on the outside of a atomic shell. It's really important because those are the electrons that are involved in reacting to the other atom, and we're going to look at it in a minute. Another thing that I want you to know is to be able to tell whether a compound is ionic or covalent. And it's really, really easy to tell. An ionic compound has a nonmetal and a metal together, and a covalent compound has a nonmetal and a nonmetal. That's it. All right. So let's look at the PowerPoint right here. So let's start with writing formulas of compounds. How do we do that? So usually a formula is a representation of a fundamental compound, and we use chemical symbols and numerical subscript. What does that mean? It means that, for example, if I have a compound, I'm just going to give you a general idea. So if I have AX as a compound and then the subscripts. So subscripts is the opposite of superscript. So it's going to have numbers at the bottom here. Let's say A and small x. These little numbers right here are going to tell you the number of atoms. And then these big numbers are going to give you the name or the symbol of the atom. This is the general formula. So an example is H2O. You see, whenever you have one atom, you don't put anything. But here you have two atoms of oxygen and two atoms of hydrogen and one atom of oxygen. Let me give you another example. N2O3. This is two atoms of nitrogen and three atoms of oxygen combining together, right? So the formula is going to identify the number and type of the atoms that make up a compound, right? And we're going to use a subscript. And when there's only one atom, there is no subscript. So just like here, there's only one atom as oxygen, there's no subscript. It can be the other way as well. NH3, for example, N just has one atom, hydrogen has three atoms, right? Now, I want you to look at these examples that I gave you right now and see how they are all different, right? Hydrogen has two and oxygen. Why do we have this? right? Why do we have this for H2O is 2 and 1, but for N and oxygen it's 2 and 3? What about nitrogen, hydrogen? Now it becomes 1 and 3. What the hell is happening? And what's happening is that they're following a certain rule that we need to know about. They are following a certain rule. And to show you where the rule comes from, let me show you what's happening on a structural level now that we know the atomic structure. So on the structural level, H2O is, what is it? It's oxygen, right? Remember that the way we write oxygen is 6 valence electrons, so it's going to be 2 pairs and 2 free electrons. And hydrogen has 1 electron. And guess what happens? 2 hydrogens. Only free electrons are the ones that react. The pairs don't react. So H2O is this molecule that's using 2 hydrogens and 1 oxygen. That's why. And look at what happens when you have NH3. N has 5 electrons. So 1, 2, 3, 4, 5. What does that mean? It has 3 electrons that are free. So 3 electrons that are free are going to take up how many hydrogens? 3 hydrogens. Why? Because we have the hydrogen can only take 1. You see how it's happening? So this is where it comes from. This is where the formula comes from. And an example is, again, H2O, hydrogen is going to bind. So this is another illustrative example of what's happening in H2O, right? So this is where it comes from. But the problem is this. You cannot, if I ask you a formula, you cannot always just do a graph like this, right? Or if, for example, look at the N2O3 example that I give you, it's going to be pretty hard for you to do a graph for this one. So we're going to follow a different rule. And this is what I call a cross rule. And let me give you an example, like an idea of where the cross rule comes from. So going back to this, we really need to know the charges, right? The charges for each element. And after we know the charges, right? After we know the charges, so remember, the first one has +1, the second one has +2, third one has +3, and then this fourth one can be plus or -4. Then you have -3, -2, -1. We really need to know this. And we not only need to know this, but we need to remember where they come from. Where do they come from? They come from the Lewis structure, of course. So looking at the Lewis structure, every group has a similar Lewis structure, meaning that it has the same number of electrons in the outer layer. And because of that, it's going to behave the same way. So this right here is going to give away 1 electron. That's why it becomes H+, because they give out 1 electron. And so on and so forth. 2 electrons, 3, 4, 5. So this is where it comes from. The Lewis dot structure, right? And it gives you the charges, and then these charges are going to give you the cross rule. So when you have that, right, now that we looked at the Lewis structure, we're going to, for example, if a Lewis structure has 1 electron to give here, and on the other side, the Lewis structure has 1 electron to receive, is going to be a one-on-one relationship. One-on-one relationship. So that's why you have H and F, right? You have things like HF, HCl, they are 1 to 1. But look at what happens when you go to oxygen here. They have 2 electrons that are free. So you will need 2 hydrogens here to bind to 2 oxygens, to bind to 1 oxygen. So that's why it becomes hydrogen needs to be 2 to bind to oxygen. Or sodium needs to be 2 to bind to oxygen. You need 2 sodiums. So this is where it all comes from. It comes from their Lewis structure, but it's manifested with their charges, right? So going back to what I call the cross rule, which is the best way to find the formula, is that if you know the charge, right? If you know the charge, so let's say you have sodium, and you know the charge of sodium, you are going to, so the charge of sodium is +1, and then you have oxygen, and the charge of oxygen is -2, right? The rule is that the compound charge is 0. A total charge of a compound is 0. So if you have -2 plus 1, you're going to need another atom of sodium so that we have +2, and then +2 minus 2 is 0. So the charge needs to be 0. So it needs to be Na2O. All right. So is that hard? Then I'm going to show you the cross rule. The cross rule, after you have the charges, is even easier than that. You're going to just make a cross between these two. Make a cross between these two. And that means that Na gets 2, oxygen gets 1. All right, let's do another example. Aluminum and then chlorine. Aluminum, the charge of aluminum is +3 from the periodic table. This is aluminum. Chlorine is -1 from the periodic table. So you're going to have -1. And then when you do the cross, it's going to be aluminum, chlorine, 3. This is where the formula comes from, right? So let's look at another example. What if I give you nitrogen and sulfur, for example? No problem. Nitrogen has -3. What about sulfur? Sulfur has -2. So you go back to your cross. You put -2 here. -2, not -3. So -2. And then you do the cross. And it's going to be N2S3. You see how you use the cross? This is what I call the cross rule. And again, you can use it for metals and non-metals. So if you remember the ionic and covalent, so a metal and a non-metal, this is ionic. Metal, non-metal, this is ionic. But this one is a non-metal and a non-metal, so this is covalent. Right? So you can use the cross rule for a covalent or an ionic compound. Now, there are some things in the cross rule that you find that might be a little bit confusing. So I'm going to show you. When you get some like calcium and oxygen, calcium has +2 and oxygen has -2. When they are the same like this, you're going to simplify them. You're going to simplify them so that they become 1 and 1. So this one is pretty much +1 and -1. So the formula between calcium and oxygen is CaO. Right? It's not Ca2O2, it's CaO. So you need to simplify when they can be simplified. Another example is if you can simplify them. What do I mean by that? Let's say, not nitrogen. Let's say carbon is -4. Oxygen is what? It's -2. So it's 4 and 2. But because you can simplify them, we do just that. So we put 2 here, we put 1 here, so that it's CO2, right? So that's the only time when you might be confused if you can multiply them. But again, don't be confused. All you have to do is simplify them, right? So if there are numbers that can be simplified, simplify them. But most of them are just going to be 1 and 2, 3 and 1, 2 and 3. You don't have to simplify anything. All right. So that's the cross rule. That's the cross rule, and that's how we predict formulas when given any two atoms. Okay, now let's look at an example. So they are telling you to predict the formula of the ionic compounds formed between these two elements. So the first one is sodium and oxygen. So I think we've done this one, but we can do it again, where you give me sodium, give me oxygen. Sodium charges +1, oxygen is -2, so it's going to be Na2O. All right, another one is lithium and bromine. So again, lithium, if you go back to the table, the charge is +1. Bromine is what? -1. So the cross will give you LiBr. And then aluminum and oxygen. This is a good one because aluminum is +3. Oxygen is -2. So when you do the cross, you're going to get Al2O3, right? So aluminum gets 2, oxygen gets 3. That's the cross. Remember that. All right. What about barium and fluorine? Barium, going back here, barium has, where is barium? Barium is down here, right? So that means that it has +2. So barium and fluorine, barium has 2. So Ba and F, it has +2. F has -1. You do the cross, it's BaF2. That's the cross, right? So that's how you find the formula, guys. There's no other secret. That's it. That's all you do. The cross rule. The cross rule is your friend, and make sure that you do it, you practice it. Make sure that you go back and you look at the charges to make sure that you remember all the charges, okay? But that's the cross rule. That we use it to predict formulas and to predict formulas of compounds, right? Now that we're done with making formulas, let's go to naming these compounds. How do we name these compounds? All right, so this is where I go back and remind you that we have two types of compounds. You have ionic compounds and covalent compounds. So this is a reminder because it's going to be interesting. It's going to be important. So ionic compounds, it's going to be metal, so it's just M, and non-metal. And then covalent is NM plus NM, non-metal plus non-metal. So remember this. And it's important because we name these differently. So if I give you a compound and tell you to name it, the number one thing you have to do is to tell, is this an ionic compound or is this a covalent compound, before you go on to naming it. So let's start by ionic compounds. How do we name ionic compounds? It's pretty easy. You start by the name of the first one, the name of the metal, right? From the periodic table. So here, if you can look at this down here, you have sodium is the first one on this one. You have lithium, aluminum, calcium. That's what you start with. You start with the metal or the cation, right? Remember that the cation is the positive ion. So you start with the metal, and then you add the non-metal at the end, or the anion, right? So this is where you just have to, this is where you change it. So the second one, the non-metal, you don't write the whole non-metal. You write a stem of it, and then you add IDE to it. IDE to it, right? So if it's chlorine, it's chloride. So this is sodium chloride, right? So this is sodium chloride. This is sodium oxide. So for oxygen, it's oxide. For sulfur, it's sulfide. For bromine, it's bromide. For oxygen, it's oxide. The beauty of this is that the non-metals, is not that many of them. So we can just, remember them, right? When you have bromine, is bromide, chlorine, chloride, fluorine, fluoride, hydrogen, hydride, iodine, iodide, nitrogen, nitride, oxygen, oxide, phosphate, phosphide, sulfate, sulfide, right? So these are the non-metals. Remember that the non-metals is not that many of them. So that means that after you know these, and again, it's just the stem, and then you add IDE. And after you know this, you can be able to name any of these non-metals. So NaCl is sodium chloride. H2S is hydrogen sulfide. NaF is sodium fluoride, because this is fluorine. This is barium chloride. Magnesium nitride, right? Nitrogen is nitride. Potassium oxide. So if you have a periodic table and you remember these ones, you'll be able to name any ionic compounds, right? And remember that these are ionic compounds, and we have two ions. So these ions are the most common ions, but remember that these are monoatomic ions. These are monoatomic ions, but sometimes you have other types of atoms that we call polyatomic ions, right? So these are just monoatomic ions here from the periodic table, right? But again, this is why I gave you polyatomic ions early on, so that you can start memorizing them, because this is where we're going to know them. We're going to have to know these, right? Because we have to know how to name these as well. So this is ammonium, nitrite, nitrate, sulfite, sulfate, right? Hydrogen sulfate, hydroxide, cyanide, phosphate, hydrogen phosphate, dihydrogen phosphate, carbonate, bicarbonate, and so on and so forth. So you'll be able to know all of this. You have to remember all of these, so that if I give you something like name this, you remember that you name them the same way, but remembering that this is a whole ion, right? This is a whole ion that's named as ammonium. So this is ammonium chloride. And then this is one, anybody remember what it's called? It's sulfate. So this is barium sulfate. And then this is iron nitrate. All right? And then this is copper bicarbonate. This is calcium hydroxide. So you have to know how to name these by remembering your polyatomic ions. We need to remember this. These are important. But again, going back, we need to just remember this, and remember their charges as well. And by the way, guys, going back to making our formulas and our cross rule, right? The cross rule also applies to their polyatomic ions. It applies to their polyatomic ions. So if I ask you to give me a formula between ammonium NH4 plus and chlorine, which is -1, right? It's going to be +1 here and -1 here, and then you do the cross. This is just NH4Cl. It's a 1-to-1 relationship. But look at what happens, for example, when I say between sodium, for example, and phosphate. Phosphate is PO43 negative. That's why we need to also remember the charges. That means that sodium is +1, phosphate is -3, and then you do the cross and look at what happened. It's Na3PO4. All right? So the charges work just like in normal atoms. Again, these polyatomic ions, they act as single atoms, but it's just one group of atoms that act as a single ion. And another interesting thing happens, by the way. Let's say on this side, let's put, let's see. Let me just actually make a new window. Let's say you have aluminum. Anybody remember the charge of aluminum is +3. And then let's say I have nitrate, NO3 negative. And you got to remember the negative so that you know that it's the charge of -1. And then I asked you, what's the formula? So you do the cross, and when you do the cross, look at what happened. Aluminum gets 1, and look at nitrate. NO3 gets 3. How do you do 3? Parenthesis. So NO3 gets 3. Aluminum nitrate. It's going to be AlNO3, 3, right? And it goes through the cross rule just like we did others, all right? So you got to remember the cross rule. Remember the cross rule. Remember naming whether you have polyatomic ions or single ions that we call monoatomic ions. So now going back to the naming, can you name this thing? Yes, you can, because this is nitrate, this is aluminum. So it's aluminum nitrate, right? Aluminum nitrate. Now, let's go back to naming the ionic compounds. One thing you'll notice is that we don't care about the numbers. It's very, very important. We don't care about the number that's down here. Look at this. This one has 2. This one has 2. This one has 3, right? So you have different numbers, but we don't care about them, right? We don't care about these numbers. We just name the metal, and then we name the non-metal. Or whenever we have polyatomic ions like this, we name the metal and then we name the ion. So this will be aluminum nitrate. We won't care about the 3. That's when you have ions, ionic compounds. Because when we get to covalent compounds, it's going to be a different story. So I need you guys to remember that. But before we get there, right, now that you know the name, I can give you the name. Now that you know naming, I can give you the name, and then I can ask you for the formula, right? Look at this. If I ask you what's the formula for sodium sulfate, right? You'll say like, oh, sodium sulfate. I know sodium. Sodium is Na, and I know the charge is +1. And then you say, I know sulfate is SO42 minus, and I know the charge for this is -2. And because you know that, you're going to do the cross, and it's going to be Na2SO4. All right? That's what we do. That's what we use. And then, for example, if I have magnesium phosphate, same thing. Magnesium is +2. Phosphate is PO43 minus, meaning that it has a charge of -3. So if you do the cross, magnesium gets 3, phosphate gets what? It gets 2. So phosphate PO4 gets 2. That's magnesium phosphate. Has to have a 3 there and a 2 there. So now you know how where all of these weird numbers come from. Now before I go to naming covalent compounds, I need to tell you how to name these weird compounds that we call transition metals. So let me just say naming transition metals. So first of all, what are transition metals? Transition metals are these metals right here in the middle in the periodic table, right? And these are these weird metals. These metals are pretty weird. The one in the valley of the periodic table here. There's a reason why we skip them. And I could talk too much about them, but they are really weird in that they don't have a set of charges. So remember that I gave you the charges for all of the others, but I skipped this. I skipped this because these ones can have different charges. They can have different charges. All right. So iron, for example, iron Fe can have +2 or +3 as charges, right? So iron can have +2 or +3 as charges. And because of that, we have to specify the charge in the name. So we have to specify which charge in the name. And the way we do that is we use Roman numerals. What do I mean by that? Iron chloride versus iron chloride, right? FeCl3. They are both iron chloride. So how are you going to tell? So we're saying we will say this one is iron 2. So we use Roman numerals. Iron 2 chloride. And then this one is iron 3 chloride. So they are different in charges. And you have to specify those. So for transition metals, when you're naming them, you have to specify the number in the name. All right? So that is how we name ionic compounds. Just to recap, we name ionic compounds by starting with the name of the metal and then the name of the non-metal. And the names of the non-metals are just these prefixes, and then you add the IDE, right? And because the non-metals are limited, we know all of this and we can just name all of this, no problem. The only exception that comes in is when you have polyatomic ions, right? Polyatomic ions also form ionic compounds of polyatomic ions, and these ones we need to also remember their names so that we can know how to name compounds like these. But we name them the same way by starting with the metal, like iron in this case, and then you say nitrate. But for example, for this one, now that you know that transition metals like iron, you need to specify this will be iron 3, right? Iron 3 nitrate. So iron 3 nitrate. You have to specify, right? And then this one is copper, right? Copper HCO3 is like bicarbonate, and it has 1. So this tells you that this is a special type of copper, by the way. It's a special type of copper that has 1. So you say copper CO2, copper CO, copper 1 bicarbonate. So whenever the metal is a transition metal, you have to specify what charge it is. All right. So that's how you name all the ionic compounds, and I'm going to give you a few exercises on how to name these. Now let's go to naming. And remember that another thing again is after you know the name of the compounds, you should be able to, if I give you a name, to give me the formula. So if I give you like barium chloride, you know that it's barium, right? That's +2, I think that's what we found. Chloride is from chlorine, that's -1. So you know that this is BaCl2, right? And you can also try these ones as well. It's the same idea. Whether it's single ions or polyatomic ions, you do the same idea. You do the cross rule, all right? Okay, so let's go to when you have covalent compounds. When you have covalent compounds, right, you have to include numbers in the name. That's the difference. The order is how they appear on the formula, but you have to include the numbers in the name. And how do you include the numbers? If it's 1 is mono, if it's 2 is di, tri, tetra, and so on and so forth. So if you have SiO2, the first thing you will notice that this is a covalent compound. If it's a covalent compound, now you have to care about the numbers. So Si is silicon, O is oxygen, so it's silicon dioxide or monosilicon dioxide. This is dinitrogen pentaoxide, right? This is monocarbon tetrachloride. This is iodine heptafluoride, right? So you use these prefixes to specify the name of it, the number of it, but I can't stress this enough. It has to be covalent. So that's why when in terms of naming, the number one thing that you have to know is you have to make sure is this covalent or is this ionic? If it's covalent, that's when you specify the number. But if it's not covalent, you don't. All right, you do it just like we were looking at ionic compounds. Right? It's really, really important. But again, if it's just covalent compounds. So one of the most common covalent compounds is H2O. And this is water, but the technical name is what? Dihydrogen monoxide, right? Water is dihydrogen monoxide. NH3 is covalent too, so is mononitrogen trihydride, right? So we need to specify it. We need to specify it whenever it's covalent, to specify the number. And it's really beautiful when you know a covalent name, because when I give you a covalent name like this, then you'll be able to give me the formula, because the formula is in the name. Right? So nitrogen monoxide is one nitrogen and one oxygen. Dinitrogen tetroxide is two nitrogens and how many oxygen? 4. Diphosphorus pentoxide is two phosphates, two phosphorus, and then 5 oxygen. Nitrogen trifluoride is one nitrogen and how many fluorine atoms? 3. Right? So it's in the name. So it's easier to go from name to formula when it comes to covalent compounds. All right. So again, to recap, for what we looked at today, right? For any two compounds or for any two atoms, right? For any two atoms, you gotta be able to tell me if they are ionic or covalent, right? You gotta be able to tell me the formula between them. You gotta be able to tell me the name between them, and then you gotta be able to tell me if there is polarity, right? And we talked about this another day, all right? And also, so this is number 1. For any two atoms, you should be able to know that. And you have to remember polyatomic ions too. Polyatomic ions too. And then you have to be able to know, let me see if you can see this. Know how to go from name to formula or from formula to name. So I can give you a name and you give me a formula, and then or I can give you a formula and you give me a name. And again, when given a formula to get a name is these rules that we've been looking at. But when given a name to give me a formula, again, you use the cross rule that we talked about. All right. The only thing is, remember that in the cross rule, polyatomic ions count to. All right, so that's everything that you should be able to tell me from this video. All right, but if anything doesn't make sense, uh, go ahead and replay it. Practice with the practice questions that I'm gonna give you. But of course, if it still doesn't make sense, please send me your questions and I'll be happy to answer. And that's it. That's it for this class, and I'll see you next time. Bye bye.